Hi. Today we'll be talking about changing live audio with the Web Audio API. The thing is, I have a guitar here, and I will try to alter the sound with the Web Audio API. First things first, my name is Bellen. I'm a front-end developer at Made with Love. You can find me on the internet as @sammego or GitHub sammego. Then, to start, I'm a guitar player, and at my home I have a lot of these pedals which give effects to your guitar, make them delayed or give them a rough sound. And I started wondering, like, how do these work? Can I make them myself? The answer is, of course. So I started with some electronics, building them in real. And this was fun, and it got me to know a bit how effects work. And then the logical step, I'm a developer, I was like, can I do this on the internet? Of course you can. And that's what I'm going to talk about today. Step one, we first need to get the sound of the guitar or connect it to the website, the web app you're making. How we're going to do this is we're going to use the Web Audio API to create a new audio context. The audio context is the basic building block of the Web Audio API. Second, I've hooked up my guitar like a microphone to my computer so I can just get the audio of the guitar by requesting navigator.getUserMedia, just the audio, and then we get a stream of the sound of the guitar. This method is deprecated and it's been replaced by navigator.mediadevices.getUserMedia. It works the same, but instead of callbacks, it just returns a promise, which then returns a stream. This only works in Firefox at the moment, and in Chrome behind an experimental web platform features flag. Then, once we have the sound of the microphone or the guitar, we just have to create an input node through the audio context, which we created first. We do audio context.createMedia stream source of the stream, and then we connect the inputs node to the output of the audio context, which is the speakers. The code like this would just send the input straight to the speakers, and you would hear the guitar. Fun, so that's half of the work, pretty easy. Then the second one, add effects to the guitar sound. This is where it gets a lot of fun. A little bit more complicated, so I will try to explain some basic audio nodes which you can find in the audio context of in the Web Audio API. The first pedal I wanted to create was a simple volume pedal, just a pedal which lets you alter the volume of your guitar. This is pretty easy. You can create something called a gain node, which controls the gain of your audio signal through audio context.createGain. It has one parameter you can just change, which is the gain, and it's just from 0 to 1, or 0 is mute, no sound, 1 is the complete volume. You connect the input node, which we created earlier, to the gain node, to the output node, and you have a new chain. Then the gain node, this is a visualization of what the gain node does. This is my audio wave, which is just a sine wave at 100%. Then if you put it at 50%, you see that the wave gets more compact. And if you put it at 150%, you see that at the top and at the bottom, the wave gets clipped. This is something you can use to make your sound a bit more aggressive. But if you want to have every detail in your sound, make sure that you stay under 100% or 1. So now my audio chain looks like this: my input, my guitar sounds, my gain node, and the output, the speakers. That's basically how you can create the guitar effect, the gain, the volume effect. The second one is a distortion pedal. Distortion is something which makes your guitar sound a bit more rock or metal, just dirty, aggressive. It's something that gets used by most electric guitar players. And we can create this effect by a wave shaper node. A wave shaper node is basically just a node which lets you alter the shape of your wave. As we saw earlier, a regular sound is just a sine wave, a smooth, even wave, like this. You can just create a fancy math calculation function which takes your wave, applies a new curve to it, and then outputs a new audio signal. An example of an algorithm to create a distortion curve can be found on Stack Overflow, because it's a bit more difficult to calculate this. It's a bit complicated math. But the result is something like this. You start with the basic sine wave, and then when you apply the wave shaper, you can see that the wave gets something totally different. You lose a lot of the detail in the top and in the bottom, but that's what makes it this cool and this aggressive. I will let you hear all the effects later so you can hear what I'm talking about. Then if you want to create a distortion pedal, it's just input, which we already talked about, the wave shaper node connected to the output, bam, distortion. The next one is a delay pedal. A delay pedal is basically a pedal which lets your sound repeat and then fade out in the end. To create this, we can use a delay node. Audio context.createDelay is a function you can use to create one, and it has a parameter delay time. This is in seconds, so this is roughly the schematic of how you would create a delay pedal. It's just you send your input to the delay node, which sends its output delayed to a gain node back to the which lowers the volume, and then back to the delay node, back and forth until it fades out. The next one is a flanger pedal. Flanger is kind of like a delay, but it has a dynamic delay time. So you will hear that when I demonstrate the flanger, it has some wavy sound in the background. We can create this by using an oscillator node. An oscillator node is basically just a node which creates an oscillator or a constant tone. It has a few parameters you can assign, like the type or the frequency, and I can show you them here. The basic oscillator is just a sine wave, which is a smooth curve. But if you choose another type, like square, you can see that it is a totally different wave, triangle, sawtooth. And then the frequency is the speed or the frequency of your tone. The lower the frequency, the lower your tone. The higher your tone. And you can see that 400 is the standard, which I've chosen, but if I put it at 1000, it gets a lot faster, 2000 even faster. And if I would put on the sound, it's super annoying. But basically, that's what an oscillator does. It creates a constant wave. By using this constant wave, by connecting the oscillator through not the delay itself, but to the value of the delay time, we can just change the delay time according to the wave, so it will go fast and slow according to the oscillator. There's a lot more nodes here which you don't have to remember. It's just basically oscillators create waves, and you can connect nodes to properties of nodes, not only to the node itself. And the last one I tried to build is a reverb pedal. A reverb pedal is just a pedal which adds some echo or echo to your pedal, to your guitar. We can use this by using a convolver node. A convolver node is basically just a node which takes an audio file and all the characteristics and then projects it into your own audio signal. So first we have to load an input response file, or impulse response file. I found one very good by Chris Wilson. He made the Web Audio Playground. You load it, you get an array buffer out of it, and then you decode the audio data by using the audio context, and then assign it to the convolver node. And this will automatically project all the properties of that sound file to your own sound or your guitar sound. And then it will look something like this, a lot of gain nodes and the convolver node in the middle. There are a lot of other nodes, which I'm not going to talk in detail because I could keep on talking for hours then. These are a few other important ones. An analyzer node, which is to analyze your sounds. You might have seen in my starting slide, there was the sound wave of me talking. You can analyze the frequency of your sound by, for example, Bigot filter node is to filter some frequencies or add a low pass or a high pass filter. Channel splitter, channel merger node is to split the channel into stereo or merge it back again into mono. Banner is also to assign your sound to a side, like left or right, or if you have surround, to front, back, all these kind of things. And dynamic compressor node is just to compress the sound so it gets more even. That's all cool and stuff, but if you want to create all these effects, you really have to remember how to create all these complex chains. So I've started creating a library which is called audio effects, and basically you can just import the distortion, assign it to your input and output, and you have it working. If somebody's interested in that, it's on GitHub. I will share the link later. But now, let's try it out. Live demo CA. I made this little app, which is just some UI on top of this audio effects library I've been building. And first we're going to just create an input which will just give feedback. Maybe we should turn off the mic for a while. Is that possible? Okay. No. Anyway, you can maybe hear the guitar or not because of the feedback, but we can apply some effects like volume, which sucks, and with this you can just, I don't know if you can hear the guitar, but you can just alter the volume. Yay. You can also, well, this mic is running, which is.
Isn't there a switch on the microphone?